Okay, so today we're going to be solving another LeetCode problem. Let's go all the way to the binary search, and you can see that we don't have any easy problems for binary search, so we're just going to move on to the linked list. Over here we have the first one, which is reverse linked list, one of the most classical problems in programming. So what we have here is reverse linked list. Given the head of a singly linked list, okay, this is a singly linked list, reverse the list and return the reverse list. This is one of the most easy questions ever, and you have 1, 2, 3, 4, and 5. You have it to have it reversed. Okay, so you're gonna have to change up the pointers, okay, so that it point like this, and then you have the example 2 where it's like 1, 2, and then it will turn into 2, 1. Okay, and then of course if head is equal to this, null, and then the output would be null. The number of nodes in the list is in the range between 0 to 5,000, and the values are like in this range. A linked list can be reversed either iteratively or recursively. Could you implement both? So basically there's two different ways, as the hint explained. One is the iterative method, and the other one is the recursive method. So over here we have the definition for a singly linked list, and then we have a struct list node, we have a value, we have a next pointer constructor that has the value set to 0 and the null pointer for the next, and then we have a list node, another constructor which has the value, puts in there, and then the null pointer, and then we have another one which has a value and the next pointer, and then it points to the next, just like that. This is basically another list node within a list node, so basically it points to that next. So this is awesome, and we have to create a list node pointer. Basically it has to return a pointer for the list node, and then it has to have the first, that's the return type, as a reverse list, and this is the list node pointer, and then it points to the head. So we have to first come up with a solution that could achieve this. How are we going to go about this? Well, there's a classic solution where you have the iterative approach, basically I'm going to go for, and that means we're just going to use a loop, and we're going to use 3 different pointers. Now let me explain what I'm talking about. If we're talking about this, first of all, we're going to have the list node pointer, which is the null. So basically I'll talk about the prev pointer, the next pointer, and then we have the current pointer. So just 1 second. If I type in the list node pointer, and then I have the prev, that will be assigned to the null pointer. Okay, if we have another list node pointer, and then we have this as the current, that would be pointing to the head. Okay, and then we have a list node pointer, and this is the next, you can basically say next node, because over here we already have, like, it's going like the, over here we have the next over here. Basically this is not gonna, like, we don't want next like confusing it, so we'll just say next node. So prev is the previous node, current is the current node, and next node is basically the null pointer at the moment. Okay, so we have these 3 pointers, and now what we're going to do is, well, first of all, we're going to say while the current is not a null pointer. While, because that's already something that's not null, rest everything is a null. So we'll say current not equal to a null pointer. Okay, like that. Okay, so now what you could go inside of this, we have current not equal to null pointer. Now the thing that we have to put inside here, so that everything works out the way we should want it to, basically we'll want to have to transfer this one. I wish I could have the ability to write on this. I know there's extensions, but I don't have anything at the moment, so I'll just use paint. Now over here we have this 1, we have a 2, 3, 4, and then we have the 5th element, which is 5. So basically 5 different nodes. They're all interconnected, right? And this is basically null at the end. We have a head we could point from there. what we want is basically we want to, the current is basically, I'll just say current with the CUR. Okay, so the current is pointing to the head. Okay, and the head is also pointing here. So what we want is we want a way where we're gonna say the current will now point to the the next node. So we have the next and the null, the previous node. They're pointing to null pointer so far, but we want our next node to point to the next of the current. So basically the current's next is this thing, right? We want our next pointer pointing here. Okay, so we want the next one here, and we also want our previous one within our current. So basically the previous one will be something like this. So when the current basically moves, when the current moves to the next node, right? When the current moves to the next node, we want the previous to be right here. Okay? Before current moves, we want the previous to be the current. Okay, so let me explain this a little bit better through code. So first of all, we want the next node, right? So we say next node. We want that to point to the next of the current. So the current right now points, you already saw by the, the current already points to the head, but we want the current's next, right? So we say current next, like that. So now we have the next node pointing there. Great. So now we have this. We want the next thing, which is the if you look over here, we have the current which is pointing to the next. Now we have to talk about the previous. So what's happening is that the current arrow next, if I look at over here, the current arrow next will have to be the previous. Okay, because we point this to the next and we assign the current arrow next to the previous. After that we have the previous, which is previous. Okay, and this would be assigned to, like I said, it was right now the the current arrow next. What is actually, look at this. So let's look at it from another point of view. We have the next node that points to the current arrow next. The current arrow next is now changed to the previous. Basically, what was previous? It was null, right? So current arrow next is also null. After that, we want to link the previous. So we say previous is now going to be the new current, okay? Because now the current will be advancing. And then you could say current is equal to the next node. It's just like a cycle. It's a chain that's happening over and over. And once we're done, we could return the most recent one would be previous. That would ultimately be pointing as our head. So if I run this, control and single, apostrophe, you can see my code has been running. And you have 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. Okay, so you can see it's it reversed all of them, and it looks really good. Let's explain this a little better. So let me just have these things removed. So Control Z. Okay. So let's start it again. So we had 3 different pointers, remember? And we have the current pointer. If you look into the code, we have 3 different pointers. Only the current one points to the head. And we say, well, current not equal to null pointer. We have the current that points to the head at the moment. But over here, you could see the next node wants to be the current. Basically, the current is this, CUR. Okay? CUR is this one. And then we have the next node is right now null. And the previous is null. But when I say next node is current arrow next, we say next node is basically, if I say just next, I'll just say next. Okay? So the next node will be this one. Next and, okay, next node. This will be over here because I said current arrow next, right? So that's first. After that, we say the current arrow next will, the thing that right now, because the current arrow next now should be the previous thing, because this is our next destination. right? So we know that previous was basically null. So we'll say that the current arrow next, or whatever it is, right? Because for right now it's this one, right? We'll say that is assigned to previous. Previous, well, what is the value of previous? Well, it was null, so initially it is null. If you can see over here, previous is null pointer. So the current arrow next will also be a null pointer. Okay, so that's good. Current arrow next is now a null pointer because we already shifted our next node. After that, we have prev assigned to the current. Okay, because the current is now the old one, and then the current basically moves to the next node, like here. So it change, and it just keeps going. It's just gonna keep going until we have over here the previous. So the prev will basically be pointing here at the end, and from here we can basically have our fix for the sequence will have prev, and it will essentially have all of these pointers reassigned. So it would be 5 and then 4 and then 3 and then 2 and then 1. Hope you like this iterative solution. Alright, so this is the iterative solution. Remember I told you that there's one more solution for this, and that's the recursive solution. I could just add it right here, so it's not a big deal. Right now I could just call this as the iterative solution. Okay. And now we go here right after this one, which is so right here I could just write in recursive solution. Okay, what is the recursive solution here? Well, you have the same thing. You have the head pointer, right? The only thing we have, and we have to check if the we have a base case. If head is equal to null pointer, okay. If head is equal to null pointer, or if the head's next is a null pointer, then we could just return the head, because we know that it's a single thing, right? So we could say return head, okay, because it's a single element. But like if it's an empty list or if it's just a single element, we could just return head. But if there's more than that, we could have a list node pointer reverse head, and then we have that basically recall this function. So whatever the function is, you can see over here, reverse list, right? So it will call this function again. So reverse head is reverse list, and then we have head arrow next. So reverse head, then we basically have head next equal to head, alhamdulillah, and head arrow next is equal to null pointer, alhamdulillah. So over here you can see that the recursive solution has a pretty decent way to solve this, and then after that we just basically return reversed head. Over here we just need an S. Reversed. Yeah. So this is how you do it. So you basically have the null pointer, or if the head is equal to null pointer, or the head is equal to null pointer, you could just return the head. If not, you could get the reverse head pointer and call the reversed list and pass it to the next, and it was just going to keep checking until it returns the head. After that, you basically go here and then you go basically check, and then you reassign that to whatever the head is, and you get the heads next, and you assign it to the null pointer. So essentially, this is another way to solve it. If I remove this, okay, the iterative solution, I could just comment this out and just run this one. It should solve this for us. Control and apostrophe. So let's see, and you can see it solved it this way as well. Okay, so good. So far so good. And basically this was the video for the reverse linked list problem, and it was pretty simple and easy. So the next time we're going to be doing the merge to sorted list, and that's also an easy problem. Alright, so stay tuned for that.